Hello everyone, I'm Xiao Gang. Let's continue learning about UObject. We actually demonstrated a small part of the powerful capabilities of UObject earlier. Now let's directly demonstrate the more powerful capabilities within these UObjects. As I mentioned a few times, let's stop here and not go into depth. You need to understand clearly whether this is a U class or an A class, when its lifecycle begins and ends, and how UE5 calculates it at the underlying level. And this reference update it has some reflection, serialization, etc. Let's talk about reflection is this U class. Steady class, we just demonstrated to him. This CDO object, it is also an application of reflection. There is also another reflection. We will actually later talk about it when discussing U function. How Blueprint calls C++ methods. How C++ calls Blueprint methods. We have some conventions, these rules. Okay, as for serialization, it's essentially how these editor assets are serialized to disk in a format like a. To store them, that is serialization. We map within this, these JODIS assets, how they are saved. And the serialization is quite complex. Actually, we should not go into this in depth anymore. We want you to look at this. Search for this as cancel search. There is this called drowse. That's it. It's the interface of OBL there. We can see. Let's go in directly, go in again, and look at the source code comments. Okay, I'm a bit laggy here. A bit laggy. Too many jumps. After we find its location, we'll just jump over from our project. Okay. Some storage service that is reading and writing. Reference collection using FFs. This is implemented. Choose your ideas of some of these attributes, then you can override some of these native variables. That is, everything we use is based on objects. Our audio, images, video, by our game class, character class, lights are all objects. How to serialize this data? The essence is through this, a series of operations within the service to accomplish. Okay, we won't go into detail. Okay. Then let's first talk about this default property chain. Auto update. What does it mean? Actually, let's use the previous example to explain. You can see we wrote a class extra. Its money is 100. If we change this 100, then all your stuff, including the subclasses generated, as long as you haven't modified the subclass, they will all change accordingly. But if you have modified the subclass, it will not change. Understand this sentence. The child you haven't modified will change along with the default child's modifications. The child you have modified will follow your, okay, very user-friendly, right? Then you can see this money we have modified, right? Now let's drag one out. We'll go directly through this and we'll go into this one of ours. We can turn off the engine stuff. Also turn off the plugin stuff first. Okay, so here we have a class actor. Okay, let's find class actor. Okay, this place is 300, right? So it's very simple. We'll close it. Then we take this 300. We change it to 400. Let's take a look first. Okay, let's look at it. Hey, 400. Isn't that amazing? Now drag out another one. Still 400. And they are still our previous 150 and 200. And we just talked about it in the previous two sections, right? Okay, next I'll look at the following. This is the official documentation. Look at this place. Look at mine. It can be the same. So what is automatic property initialization? It means I give you a value. You have a property. If you don't initialize it, it will help you initialize it. It will often initialize to 0. If it's a string, it will initialize to an empty string. If it's an int or float, it should initialize to 0. Let's take a quick look. We put this thing in the code. Where do we fill it in? Let's just write it here. This is more convenient. Let's just write it this way. We give it an uninit. We don't give it an initial value. We give it a default value, not counting. Default value should be fine with double as well. It couldn't be used before, but now it can. Because we've extended the precision, on init number, on init double, then strike A. And then don't do that, because according to our traditional standards, doing this will make this value dangling. It will initialize. The comparison control is basically, this memory region of yours is not initialized. There will be problems, but we are better at considering the situation. It will do it for you. And then there will actually be a warning. You can see, I really don't like this warning. So I always manually initialize it like before. Now let's look at this value. Let's look at this value. Because we found 0 and empty strings, so this thing is an error editor integration. These are your variables. You can control them based on red in these places. This place is an instance. Can the instance be modified? And can it be modified in its blueprint? That's the situation. Okay, then let's look at the following. Runtime type information is available. It essentially allows you to do some type casting, a type determination. It's about whether they have an ISA relationship. That's what it means. As for network replication, we will actually cover network games in detail later. Some of our properties need to be synchronized from the server. So we will go through. Did I just show you? There are several metadata in UPROPERTY. This is it? Okay. So we will use all these properties. So we won't go into detail here, because if we talk too much, because it's all a bit much. This network replication should be covered in the networking section. Yes, as for networking, after we explain the company case, you can see that I have already prepared this blueprint case for you. It should be mostly done by now. By the time we talk about it, it will definitely be done. Let's take a look. Actually, most of these things are available in USwag. What is the difference between them? It's that USwag will be treated as a numeric type. It won't be garbage collected. It won't be counted. That is, the system won't detect it and actively eliminate you. It follows our traditional C++ management method like this. So this is a very important difference. As for this Unreal header file, our UHT has already emphasized it. It's a cliche. Already one more time. Contains the generated reflection files. Use the corresponding red class, or struct red, or enum red, or interface red. Write it above your interface or class. If necessary, add the export reds if it needs to be used by external modules before your class name or type name. Must follow the necessary standards, which starts with A. Starts with U, or starts with I. Okay. Remember this and it will be fine. Then which properties should be reflected to blueprint? Which attributes should be exposed to blueprint? Which functions should be exposed to blueprint? Add UProperty, add UFunction. Okay, no problem. Okay, let's continue moving forward. The format of this header file. Probably nothing interesting to see. Then, okay, these are some metadata tags because we are blueprint type. In most cases, just setting it as blueprint type is enough. So here it means highlight this in red. This red but is usually mandatory. Just don't use class, it's fine. Generally, just take another look. Reinforce the memory. It should be written here. Look. Actually, it used to use Genity's interface. It might now be integrated into one. Following it is fine. No problem. No problem. Okay, let's continue looking below. As for that specific metadata, we'll emphasize it later. Actually, it's not emphasized much. When we use it, you'll see when you look at it. Okay, so this flag is for you. You probably won't use this as a beginner. Sometimes we have some traditional C++ programs that want to customize UE5's macros. That is to say, I need a tool now to generate such a class. But I don't want to define it. I want to define the class through macros. So you red wrapped the Unreal Red. Congratulations, this won't work. Because the Unreal Red cannot be wrapped and used by other reds like this. The correct approach. You need to work on this UBT-UHT. Go take a look how that standalone program scans and writes. Then follow it to scan these things and regenerate a set of reflection files. The correct approach should be like this. And these two reds are specifically for distinguishing this module. You don't need to look at this in such detail. What these two reds mean is cancel it. We have, as I emphasized to you before, that is, we will separate by platform. We have the Android platform. We have the Mac platform, Windows platform. Then we have two main environments. One is development. One is the development environment. One is the packaged environment. That is, one is the editor environment. The editor is the development environment. The package environment is the environment after packaging and running. So some things are not allowed to be used after packaging. So we take that code, that data, and enclose it. Generally, in this CPPP, we use this waste editor to enclose it. Then it only runs when the editor is running. These header files will be included. These methods will be defined if it is in this editor data. Generally, it is used more often in header files, generally package data. Then, if it is in at runtime, we won't have this code. So distinguish by the same token. If we are distinguishing platforms, we can use if Windows, if Android, of that is max A90. This is a cross-platform, a packaging specification. It should be in the specification. Be careful when speaking. Okay, let's continue looking. Let's still talk about this tick. Actually, many friends sometimes encounter this situation where it doesn't tick. I also encountered this situation when I first started. It's very simple. It's that your thing hasn't had tick enabled. First, take a look at what the you are an A class. A class can all tick. Then if it's A class and A class, the A protagonist ticks. If it can't, then it's because you haven't enabled it. You might have turned it off, just turn it on. And there are several places where it needs to be turned on. It might not be just a simple one place we wrote. There might be some places where some tick also needs to be turned on. We'll talk about that when we encounter it. Okay, if it's a U class, then you need to inherit from fig COMOJ. Inheriting this capability allows you to implement the tick function. Of course, there is also a simpler operation. You can directly find a tick core delegate and bind it. Just follow the tick and it's done. When we are in a standalone program, sometimes we adopt this writing style, but we still recommend following the engine's standard method to advance frame by frame. Otherwise, you'll have a problem when writing plugins. That is, at 60 frames per second. But within this one frame, your function executes twice. Then you've likely bound it to the wrong place. It's possible you called it one extra time. That's the situation. Then for this tick, its interval may not be once per frame. So here we'll paste one, subsystem's cover code. Then I'll guide everyone through writing it. What is a subsystem? Okay, as for subsystem, let me see. We'll write it later. We'll talk about it later. When we finish this chapter, then we'll write this subsystem. Let's continue reading for now. Okay, so skip this for now. Alright, this is the garbage collection we demonstrated last time. That is this part, meaning that once we have a few seconds or a few minutes later, garbage collection, this thing is invalid data. When you are in an emergency, you can attach it, but don't write it this way. Writing it this way will get you criticized, but the correct approach should be to use a smart pointer to wrap and manage it. That is, after it is no longer referenced, then it will be, for this part, you can directly check the official documentation. Some parts can be directly referenced from the documentation, taken from there. In other words, without this UPaper's underlying pointer container, object at packed f, this thing, if it's a strong reference, then it will, garbage collection will reclaim it, yes. Then a weak pointer. Then a weak pointer knows that it has been reclaimed, but it will not affect it, cause an impact. That is, this array becomes empty. It is equivalent to 1. Then the weak pointer will receive a notification. Originally, this object has been recycled and is no longer usable. It's similar to squares type. And if these objects that are being traced back, then their pointers will be set to null. Yes, and our smart pointer is t-ptr. We'll talk about this later. It is generally not used inside objects. We generally use t-object-ptr, t-wake-object-ptr. You can see that, like, there is a lot of this in Alera. A lot of this place is it. Actually, you can also use raw pointers here. Our UE4, we like to use raw pointers, and then t-object-ptr is no different. So we use it a lot because it is equivalent to an extension. At the bottom level, during our editing and development, it can provide us with a lot of information support. But at the same time, during runtime, it degrades into a raw pointer. That's the case. And then, sometimes we can judge these bytes whether it is available. Yes, then we can distort it. But I usually prefer to use set. Lifetime these without me going over them here. These are often used in our engineering practice. And here it is, destroy. Here it marks it as garbage or something like that. And actually, if you judge correctly, you shouldn't judge it that way. Actually, anyway, let's just write it like this for now. You would write it like this. understand it a bit better, you should use it. Wrap it with the object's pointer, then the point outside the chair. Do it like that. Okay, so overall, it should be most done here. Let's skip it. Then let's take a look. It's mostly done like this. But we feel it's not finished yet. We still need to look at some other methods that haven't been introduced. Let's see how it works. Okay, so we'll stop here for this lesson. Thank you all.